All right, for all of us visual learners out there, we are going to create some tree diagrams today to show the outcomes of an experiment and then play with a little bit of probability with this. Now, when I say tree diagram, I want you to actually just kind of think about the tree on the right. I know it looks a little sad, but the point is trees have these branches that kind of go off in different directions. And when we're creating a tree diagram of probability, that's exactly what we're creating. We're creating this piece that has a bunch of branches that go off in different directions that will help us get a visual on the outcomes of a particular experiment. So let's jump right in and look at this. Dan, come on, Dan. He wants to buy a car. He can choose from red, blue, or silver, and 2 or 4 door, sunroof or no sunroof. How many different possibilities does Dan have? Now, there's a bunch of different ways to figure this out, but first off, let's talk about his options. We know he can choose red or blue or silver. Okay, now we can break it down from there. This is where the tree comes in. We can also go 2-door or 4-door. A blue car could be a 2-door or a 4-door, and the silver car could be a 2-door or a 4-door. Now, don't forget, I could have a red car that is a 2-door, and then I could also go sunroof or no sunroof. So each one of these also has a sunroof or no sunroof option. So this is where this is what a tree diagram is. You have every option. So you notice line 1, red, blue, silver, we're talking about the colors of my car. Then I get to how many doors am I going to have, 2 or 4. Each color has that option. Then we get into sunroof or no sunroof. So when we're thinking about the number of options, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 options of cars, right? The combinations that Dan could choose from. Now, one thing that I want to throw out is the idea of the fundamental counting principle. So we had 3 colors. We had 2-door options, right? We're talking about 2-door or 4-door. And we had 2 sunroof options, basically a sunroof or a not. Mathematics behind this, 3 times 2 times 2. If I take 3 times 2 times 2, I get 12, which was how many options Dan had. And yes, this will always work. If you're talking about the different levels of a tree diagram, if you multiply the options on each level, we call this the fundamental counting principle, it will give you the total possible options. Now, I want to take Dan's situation here, and I want to talk about some probability. So we're going to bounce back and forth between this slide and our problem slide. What is the probability that Dan chooses a red car with 2 doors, no sunroof? Red car, 2 doors, no sunroof. That's this line right here. Notice there's only one car that fits that bill. A red car with 2 doors, no sunroof. And we know that Dan has 12 total options. So the probability that Dan chooses that red car, 2 doors, no sunroof is 1 out of 12. What we want to have happen in the numerator over our total options in the denominator. What is the probability that Dan chooses a red car with 4 doors? Well, okay, let me change colors. Red car, 4 doors. He doesn't care about the sunroof. That means both of these options are in. So we have 2 slides because red for sun, red for no sun. So now we have 2 possibilities out of 12 total. We always reduce fractions if possible. And Dan has a 1/6 chance of choosing a red car with 4 doors. All right, now we're just going to create a tree diagram. I want a little bit more practice with this. Rolling a 6-sided die, then tossing a fair coin twice. Now, a 6-sided die. 1, 2, 3, 4, 5, 6. A fair coin twice. That means first we have heads or tails for both of these. Now, I hope you notice, like I'm trying to write as fast as I can, and it's still taking me quite a bit. And now if I have to go through again and do this, you can see what my point of this example is how tedious tree diagrams can be, especially when we get to some larger type things. Now, this is where we could say 6 dice. I have 2 options on a fair side, and then I have 2 options on a fair coin. I have 24 total options here. If you are a huge visual person, then it might be worth it to you to kind of finish out the tree diagram and use this to help with probability. but sometimes it just gets too big, and using that fundamental counting principle is helpful. So I just kind of wanted to point that out, that there are limitations to tree diagrams. And thus, the end.